This video is to share some formula application of skew lines of anterior calendar curriculum, calculus, and factors coded as mcv4u. I also wrote a blog of this content at my blog site. This is my blog site. In this figure 1, lines L1 and L2 are skew lines. Factor M1 is the direction factor of line L1. Factor M2 is the direction factor of line L2. Point P is on line L1. Point Q is on line L2. D is the distance between skew lines L1 and L2. Factor N is the cross product of direction factors M1 and M2. This slide is about the letter and symbol meaning of figure 1. Here is the formula of distance D between skew lines L1 and L2, denoted by formula 1. This video is to answer two questions about the applications field of formula 1 and introduce how to use the formula to judge if two lines intersect or skew when they do not parallel or coincide. The first question, may formula 1 be used for intersecting lines? In this figure 2, lines L1 and L2 intersect at a point O. The other letters and the symbols have the same meaning as in figure 1. Since factor N is the cross product of direction factors M1 and M2, factor N is perpendicular to factors M1 and M2, and also perpendicular to lines L1 and L2. Since plane OPQ contains lines L1 and L2, factor N is also perpendicular to plane OPQ. Since plane OPQ contains line PQ, factor N is also perpendicular to factor PQ. And the dot product of factors N and PQ is 0. Then we can calculate the distance D of lines L1 and L2 using formula 1, which is 0. This slide is the reasoning process and the distance D calculation expression of intersecting lines, as I just now talked. Since the calculation result is the same as the actual distance 0 of intersecting lines, formula 1 can be used for intersecting lines. The second question, may formula 1 be used for parallel or coincident lines? In this figure 3, lines L1 and L2 parallel or coincide. The other letters and symbols have the same meaning as in figure 1. Suppose the angle between lines L1 and L2 is alpha. For a pair of parallel or coincident lines, sin alpha equals 0, since alpha equals 0 or 180 degrees. Because factor n is the cross product of direction factors m1 and m2, the length of factor n is calculated by this expression. Since sin alpha equals 0, the result is 0. Therefore, factor n is a zero factor. Now we use formula 1 to calculate the distance d between parallel or coincident lines. As the length of factor n is 0, and the factor n is a zero factor, d equals to 0. D equals 0 by 0, which is indeterminate. So formula 1 cannot be used for parallel or coincident lines. This slide is the reasoning process and the distance d calculation expression of parallel or coincident lines, as I just now talked. Finally, may formula 1 be used to determine if two non-parallel or non-coincident lines skew or intersect? It is easy to judge if two lines coincide or parallel, but how to judge whether they intersect or skew if they do not coincide or parallel? Usually, we can use the equation system of the two lines. If there is a solution to the system, the lines intersect, otherwise they skew. With formula 1, we still have another method. If the distance is calculated 0, they intersect, otherwise they skew. To sum up, formula 1 can be used for skew lines and also intersecting lines, but it cannot be used for parallel or coincident lines. The formula is also useful to judge if two lines intersect or skew when they do not coincide or parallel. That's all of this presentation. Thank you very much. Bye-bye.